derivative of natural log. So the derivative of natural log, if you remember, if you have y equals natural log of x, its derivative is going to be 1 over x, exactly. So we're going to learn about other logarithms today. What if we have like log base 7 or log base 10? Like, how do I take the derivative? So it says we know that log base a of x can be written as natural log of x over natural log of a with the change of base formula. Do you guys remember that from like algebra 2? You can do any log if you want. So you can make it log base 10 of x over log base 10 of a, whatever you want. So therefore, when we differentiate with respect to x, we get the following. Well, natural log of a is just a number. You know, if it said log base 7 of x, then it's going to be natural log of 7 on the bottom there, right? So we know that with constants, we can pull them to the front. So if I have log base a of x, and I rewrite it as natural log of x over the natural log of a, then I think of this as just a number out front. 1 over the natural log of a times whatever natural log of x is. This is all just a number. Oops, that should say constant. Constant. And we know that with constants, we just kind of leave it out front, because if we did the product rule, the second part of the product rule would be 0 anyway. So I have 1 over natural log of a times the derivative of natural log of x. Well, what's the derivative of natural log of x? 1 over x. So we write this all together as 1 over x times the natural log of a. So if you see something that looks like log base 7 of x, we know right away that its derivative, because of the change of base formula, so we think of natural log of x over natural log of 7. The 1 over natural log of 7 goes out front. Derivative of natural log of x is 1 over x. So we know right away it's 1 over x natural log of 7. That is the derivative. So that is right here. So it says differentiate the following functions. Look for tricks to make these easier. So for example, number 1, we have 5 to the x equals log base 3 of x. So we know the derivative of 5 to the x. Do you remember what it is? 5 to the x is 5 to the x times natural log of 5, yep. And then log base 3 of x is 1 over x natural log of 3. A lot of things you got to memorize, right? You're just using those formulas. Because we've done the derivative of 5 to the x before. Just like e to the x is e to the x times natural log of e, right? We just don't write the natural log of e. So 5 to the x is itself 5 to the x times natural log of 5. It's a formula that you're supposed to memorize. And then log base 3 of x we can rewrite as natural log of x all over natural log of 3. So when we take the derivative, this part goes to the front, 1 over natural log of 3, and then derivative of natural log of x is 1 over x. So it goes all together. So you should know these formulas. You should have them down cold by Thursday, because that's when your test is. You should know these. All right, so the next one. So if I have natural log of e to the 4x, okay, make it easy on yourself. Yeah, this all changes to 4x, so the derivative of 4x is just 4. Look how easy that was. If you know your laws of logarithms, it makes your life much easier. If you didn't, you would have to say, oh, this is like in the form of natural log of u, so it's going to be 1 over u times the derivative of u, which is e to the 4x times 4, and then those e to the 4x's would go away. So you could do it that way. But why waste your time doing that, right, if you can simplify first? All right, next up. So this one. That's a lot. So you can think of it in the form as log base 2 of u. So I'm going to write long way. I know you love when I write long way. So it's in the form of y equals log base 2 of u. So its derivative is going to be 1 over u, which was 4x squared, times natural log of 2, and then times the du. So the derivative of 4x squared is going to be 8x. And then you could simplify. So you could say, okay, 8 and 4 reduce down to 2, so I have a 2 on top, x and x squared, make an x on the bottom, and then you get this. So you could do that, but there's an easier way. So your easier way is to separate your logarithms first. So you would first write this as log base 2 of 4x squared is going to be log base 2 of 4 plus log base 2 of x squared. Do you guys remember when we expanded logarithms? This is what we're doing. And then an x squared, the squared can go to the front. So we get log base 2 of 4. What is log base 2 of 4? You could also rewrite that. 2. So you get 2 plus 2 times log base 2 of x. So when we take the derivative of 2 goes away. It becomes 0. And then the derivative of 2 times log base 2 of x is 2 times 1 over the natural log of, x times the natural log of 2. I'll write the x first. Is that the same thing? Yep, exactly the same. So if you expand logarithms, a lot of times it makes derivatives a lot easier. Yeah?
I just don't know how you understand how you get the 1 over x and
That's the formula that I just showed you. These are all just formulas. You have to memorize them. You gotta know them. Just like you memorize product rule, quotient rule. These are all rules that you have to know.
on the test, will there be problems that we have to
No, you can do it the long way, yeah. Just might run out of time, right? So, all right, so this next one.
I thought the other way was easier.
You did? That's fine.
Yeah, I thought the
Okay. Well, there are going to be ones that it's not going to be just as fast. So, like, look at number 5. Number 5 would involve the product rule for the derivative of the inside. So. All right, so this one, you could look for different ways to make this easier. One thing that I would do, like, I would see that you can pull the 2 up as a power. Does that make it a little bit easier? So then you could rewrite it. So you could say, oh, this is the same as x times log base 10 of square root of x squared, which becomes x. So you could do it that way. And then you'd have the product rule still. But we're going to have a product of x times log base 10 of x, like that. So we're going to have y prime equals first times derivative of the second. So the derivative of log of x, or log base 10 of x, is 1 over x natural log of 10, plus derivative of the first is 1 times log base 10 of x. So the x's cancel. So we get 1 over the natural log of 10 plus log base 10 of x. Yeah.
Why don't you just write like log of x?
Yeah, you can write log of x, yeah. You guys see what she's saying? Log base 10 is the same as log of x. Now, could the AP test write something weird? Yes. They could definitely like try to combine these by writing this as like natural log of x over natural log of 10 using the change of base and then combining. So you could have 1 plus natural log of x all over natural log of 10. Do you see how the AP test can be annoying? Right, really annoying. But that's probably how they would write it. It is. It is very annoying. Sorry. I think they just sit in a room and they're like, how can we make this difficult on people? All right, so the next one, let's go ahead and expand. So if we expand this, we're going to get y equals log base 5 of x plus log base 5 of e to the x. You could pull the x to the front if you want to and have log base 5 of e all times x. We'll leave it like this. So when we take the derivative, we get y prime equals 1 over, do you guys have it down yet? X times natural log of 5. It's always natural log of a number. It's never natural log of x. A lot of people do a natural log of x there instead. They do like 1 over 5 natural log of x. All right, and then plus, a little bit harder. This is like a u. So if we had a u there, it's 1 over u, which is e to the x, times natural log of 5, and then all of it times du, e to the x. This is in the form log base 5 of u, which has a derivative of 1 over u, natural log of 5, times the derivative of u. The chain rule, yeah. So these cancel. So basically, if you had pulled the x to the front, do you guys see what would work? What you would get? If you had pulled the x to the front, you would have had x times log base 5 of e which is x times a number. So we end up just getting that number out. Okay, so the number is 1 over the natural log of 5 if you work it out, if you change it around. Do you guys see what I'm saying? So like if this was y, then y prime equals just the number, because it was x times a number, just like if I had 7x, its derivative is 7. And then you could rewrite this as natural log of e all over natural log of 5. Well, what is natural log of e? It's 1. So that's how we get the 1 over natural log of 5. So there's lots of weird things, lots of ways you can change things around.
How do, like, where you left off in the black, where you just canceled the e to the x, like, how do you, where does the x go?
Okay, so the e to the x's are gone. So then, what do you, like the x from the formula, is that what you're saying? It was the u.
Still a 1 over x, actually.
So we have 1 over x natural log of 5 plus 1 over natural log of 5. That's our answer.
Oh, okay.
Could the AP test do something weird here? Think like the AP graders. What if you wanted to combine these? Get common denominators, right? So you could get common denominators. You would have an x and an x here. And then you'd have x plus 1 all over x natural log of 5. So they could do weird things. So always keep that in the back of your mind. Yeah, Sydney, did you get your question answered? Did you get it?
Why in the red is the answer different? Oh, that's
It is the same. I'm just saying, like, why could it end up being 1 over natural log of 5 if you had, so if at the very beginning, if I had brought that x to the beginning, like, this is what I was saying. If I brought the x to the front and then did, like, product roll or something. You don't really need to do product roll because it's x times a number. So its derivative is the number. And then that number, it looks different, but it's exactly the same as 1 over natural log of 5 because the change of base formula does it like that. So you kind of go through those steps. So it's frustrating. I get it. I have taken many a AP test on this section, and I am frustrated because I'm like, oh, this is not the form, and then I have to like manipulate it to get the other answers. So it's annoying. All right, so it says some functions are so complicated with powers, products, quotients, that they can be simplified by taking the log of both sides. So sometimes you get problems and you're like, what? I have to take the derivative of this? Like number 1, I said differentiate the following functions. And you're like, oh my God, I have to take the derivative of that? You should be saying, oh my God, I have to take the derivative of that because it's product rule, chain rule, quotient rule, right? That's a lot. So there has to be an easier way, right? So the easier way is with something called logarithmic differentiation. So if you see that you have a whole bunch of powers, a whole bunch of products, quotients, and so on, if you take the natural log of both sides, it will make your problem much easier. Are you covering for?
No, my E is, but you're referring to something else.
Okay.
Sorry.
All right, now the convenience of taking the natural log of both sides is that we can now break apart the log, right? So do you guys remember how we did that expanding logarithms? That's what we're going to do here. That's the whole reason we learned that.
Oh, I get it.
Okay, so on this right-hand side, the left-hand side is still just natural log of y, and I haven't taken a derivative. I've just written natural log in front. So now I'm going to rewrite this other side as natural log of x to the 2/3 plus natural log of x to the 4th minus 1 to the 1/2. Do you guys see where I got the 1/2? Because it was a square root. Minus natural log of 5x minus 1 to the 3. So I broke it apart with the product, became a sum. The quotient became the minus.
If you want to keep it as plus, and then you could have it to -3.
Yep, you could keep it as plus and have a -3 as well. Yep. But now we're going to bring those powers to the front, right? So we're rewriting, so we have 2/3 times the natural log of x plus 1/2 times the natural log of x to the 4th minus 1 minus 3 times the natural log of 5x minus 1, like that. And we still have not taken the derivative. It says differentiate. Find the derivative, right? So from here we take the derivative, but we do it implicitly. Remember implicit differentiation? Whenever you have a y, dy over dx. So what's the derivative of natural log of y then? 1 over y times dy over dx, exactly. So don't forget that dy over dx. So now find derivative. And it ends up being much easier because now I have 2/3 times natural log of x. Well, it's going to be 2/3 times derivative of natural log of x, 1 over x, right? So I'm going to have 2/3 times 1 over x. plus 1/2 times, this is natural log of u, so natural log of u is going to be 1 over u, so 1 over x to the 4th minus 1 times du. What's the derivative of u? 4x cubed, exactly. Then we do minus 3 times 1 over u is 1 over 5x minus 1 times derivative of u is 5. And we just clean it up a little bit. So I'm going to do 2 over 3x plus the 4 and the 2 at least reduced down to 2. So I'm going to have 2x cubed all over x to the 4th minus 1 minus 15 over 5x minus 1. And that's all equal to 1 over y. So at the very end, I just multiply the y over. Yeah, Katie?
Why aren't you doing the ln on the bottom of those? Those have to be like the derivative formulas.
No, we're doing the derivative of natural log of x, which we learned earlier in the section. So it's not like a log.
Oh,
Yeah. So we multiply the y over. Okay, and we leave it like that. So you don't have to write, like sometimes like you might see what y was equal to. You can write a bunch of that junk over here, but if you just leave it as y, I'm cool with that. So I don't make you rewrite what y is. Did you guys see how complicated y was? So I don't make you write x to the 2/3 times the square root of x to the 4th minus 1 all over 5x minus 1 cubed. I get that you guys know that y is equal to that. Just leave it as y. Okay?
You want me to contest now?
I'll show you the ones where it will be like that. All right. So let's try the next one. So this one is one where you put the y in at the end. Okay, what is weird about this one? Think about it. You cannot, don't write this, but you cannot do y prime equals square root of x times x raised to the square root of x minus 1. You can't just use the power rule. Do you guys see why we aren't allowed to use the power rule? Because there's like but what's special with power? It wasn't a number, right? It was like square root of x. It's a variable. Okay, so whenever we have like x's as powers, right? We learned one for like 7 to the x. It would be 7 to the x natural log of 7, right? But we haven't learned anything that's in the form x to the x. Like there's not a rule for that. How do we find the derivative? The only way we find the derivative when it's like x to the x or x to the sine x or x to the e to the x, anything that has like a something with x in it raised to something with x in it, we do logarithmic differentiation. We always do, okay? So maybe write yourself a note. Always use logarithmic differentiation if you have something with x raised to something with x. So I'm writing like f of x to the g of x. Okay, you have to, because we don't have a rule for that. We don't have a rule for like x to the x, okay? So we're going to do the natural log of both sides because that allows us to pull the square root of x to the front. So we get square root of x times the natural log of x is equal to the natural log of y. We have not taken a derivative at all. Okay, now we take the derivative. We do. So we do 1 over y dy over dx equals first is square root of x, derivative of the second, plus derivative of the first. You guys have derivative of square root of x down. 1 over 2 root x times the second just as it is, natural log of x. Okay, there's not much you can do here. You could combine square root of x over x plus natural log of x over 2 root x. Not much you can do. All right, that is not equal to dy over dx though. dy over dx is going to be all of that. Yeah, times your y. Now, would it be easy for the AP test to put x root x instead of y? Yeah. So, or x root x. Because that was equal to y, right? Look for weird things. Square root of x over x, you could simplify. It would become 1 over root x. you could then get common denominators with this one. Do you guys see all those weird things? They do weird things. I'm sorry. I don't know what else to tell you.
We don't have to do that on our.
You don't on your test, but look for things like that. Yeah, Katie?
Where did you get the 1 over 2 root x from?
From the derivative of the square root of x. So the derivative of square root of x, since this is x to the 1/2, it's 1/2 x to the negative 1/2. So what I've been telling you guys is it's easiest to just know that that's 1 over 2 root x. It's faster. All right, so this next one. A lot of stuff going on here. If we did do it the long way, we would have quotient rule and chain rule, right? Okay, so if we can take the natural log of each side, it might make it a little bit easier. So I'm writing it as a 1/4 power. It's the same as 4th root, right? We can pull that power to the front, or you could bring the 1/4 power into both the top and the bottom. Like write it as parentheses to 1/4, parentheses to the 1/4 for both of them. But I'll just go ahead and bring it to the front. So we have 1/4, and then we have natural log of a quotient. So we're going to write it as parentheses, natural log of x squared plus 1 minus natural log of x squared minus 1, parentheses. So see how the 1/4 could go into both of those? So let's go ahead and do that. So it's the same as 1/4 natural log of x squared plus 1 minus 1/4 natural log of x squared minus 1. So that's what I was saying here. Like you could have written natural log of x squared plus 1 to the 1/4 x squared minus 1 to the 1/4. You could bring the 1/4 into both of them, and then it would end up being the same thing. So don't worry about like which way you did it. It's the same. All right, now we take the derivative. So we're going to get 1 over y dy over dx equals 1 over 4 times 1 over x squared plus 1 times the chain, 2x, minus 1 over 4 times 1 over x squared minus 1 times the chain, 2x. Okay, then we just clean it up a little bit. 4 and 2 reduce out. 4 and 2 reduce out. So we have dy over dx equals 1 over 2 times the quantity of x squared plus 1 minus 1 over 2 times the quantity of x squared minus 1, all of that times y. Ah, dang it. X, thank you. I'm going to give it to Ariana and Natalie, actually, because you guys, I saw the hand and I heard the voice. All right, good? Do you guys understand it? It's kind of weird, but yeah, it is. I mean, you have to use it on some of these problems, so you don't have to on like number 1 and number 3. It just makes it easier. All right, so I'm going to stop that.